Hi, in this video I want to talk about the idea of objects in Java and then look at a particular kind of object, the Java string, and look at how strings can be manipulated a little bit. So in particular, we want to talk about the difference between what's called a primitive type and object type or reference type, and then to see how something called dot notation is used to call a method from an object, and to learn about the string type and the powers it has. So in Java, primitives hold a value. What am I doing there? So for example, if I make an int number equals 1, it's a reasonable mental model to think about this variable number having a 1 assigned to it, and really that variable is holding the 1. In contrast, when we talk about an object, and a string variable is an example of an object type, and we say name equals David, it's no longer quite correct to think about name actually holding these letters. Instead, name holds a reference to this group of letters somewhere in the computer memory. So I'll talk about that more in just a second. When we have an object type like string, and notice also usually object types are capitalized to start and primitives are lowercase. But when we have an object type, it's important to think of it as having sort of expanded capabilities in a primitive. So an object type holds data. In this example, it holds these characters like David, but also knows how to do things to it. So it has actions that can be performed on that data, and we'll look at that in a second. And there's a certain style of how we interact with the data inside an object. We're used to writing these static methods like length of string. Maybe you pass a string into it and it would return an int of how many characters are in this string. So information comes in and information comes out. In object-oriented programming, we have an object like this string David, and we ask it to do things for us. So tell us your length. Notice we're not passing a string into length. We're asking the object itself how long it is. So this notation is called dot notation, and essentially you have an object on the left. Either that's a raw object like string David, or it's a variable that evaluates to an object like name. And there's a period. And normally you don't put spaces there. I just have it spaced out so you can kind of see it. So you have a period and then the name of the method. And this kind of method is not a static method. It's called a non-static or object method. And it works on the object that calls it. So for example, if we had an object dog, we would ask it to speak. Notice we don't say bow wow or something like that. We just say speak. Dog looks at what's stored inside it and decides what it's going to produce based on its own internal data. So like I said, these object variables or reference variables hold a reference to the actual object in the computer. And that, you can sort of imagine why we need to do that. We don't know how long that's going to be, for example. Maybe it's 100 characters, maybe it's 2. And so this gives it a little flexibility as to decide how much space or where that should be in the computer. We can also, so right now here I have the string David is assigned to the variable name. I can also have name, it's still a string type, but it's referencing no object now. Null is a keyword that says it's the absence of an object. And I always say it's different than like 0 is for an int. 0. This is a common starting place for an int, but 0 is a valid int, right? It's a kind of int. Null basically means there's no string here. So it's not like a 0 string, it's just like the absence of a string, which is a little different. Okay. In Java, most stuff is object-oriented, so you're working with objects a lot, and it's a great development tool when we write our own code because these objects help us organize basically data and the things that work on the data together in one sort of package. And so it's nice to use this object-oriented approach to kind of manage larger projects. When you define a class, like here, you're actually defining a new type in Java. So you can make objects of this type. Right now we're using a class as just sort of an organizational tool to have a bunch of methods in it, but eventually we'll start making classes that are more like string, that have data and actions associated with it. But string, what is string? Well, you can go find in Java somewhere there's a public class string that has a bunch of code in it. And so someone wrote this stuff and makes string work. So string is a type. Let's see what we can learn about string. So first of all, when you have a string, again, it's a bunch of characters between double quotes. Internally, we can access those characters one at a time. And we do that through what's called an index number. And an index tells us which character we want. So down here, I have the string, a bunch of characters, and each character is associated with a particular index value. The one thing that causes confusion here is that the very first character is associated with an index 0. So a lot of you want to say like first character, index 1, second character, index 2. Instead, it's first character, index 0, second character, index 1, and so on. This causes a lot of little errors in code if you're not in control of that. What's the reason for that? Well, really, you should think of the index as saying how many characters you want to skip forward. Okay, that's the right mental model. So index 0 means skip forward 0 characters, so we're right at the very first one, D. Index 1 means skip forward 1 character from the beginning, so we get to the A. All right, so just kind of keep that in mind. We start at 0. Notice there are 5 characters in this string, and we go 0 to 4, right? So the 5th index is illegal, and in fact, if you try to use the 5th index, it gives you an index out of bounds. So how can we use the index in various stuff? Well, there are methods that allow us to do things to the string, and we can use an index there. Let me get rid of this null for a second. So I have name here. I'm going to, let's do some printouts and kind of look at some values of things. So I'm going to print out name dot notation, length, and notice I'm putting spaces here. I wouldn't normally, but I want to be able to show a little more clearly. We are calling a method here, so there are the parentheses, right? It's not just dot length and that's it. We're calling this method, and it says work on whatever string is stored in name. So if I run this, you get a 5. There are 5 characters in David. Let me just kind of put that back. Again, we don't normally put a ton of extra spaces where they're not needed. I'm going to copy that, and I'm going to use a different method here. I'm going to use the charAt, character at some location. This method returns a primitive, a char, a character type. So if I run this, I get 5 for the length, and then I get D as the character at index 0. And of course, if I make that index 1, I get the A, which is this one here. I can also, and actually let me do so 5 is not a valid index, 0, 1, 2, 3, 4, and if I run it, I get this exception, string index out of bounds. In other words, I have an index that's illegal. I'd have the same problem if I typed in -1 here. Out of bounds. That doesn't exist. So you might see that error sometime. And notice it tells you, where this is, right? I can click that, and it shows the error. Oops. Get rid of that. You can also pull out a sequence of characters. So if I do the substring, and I go from index 1 up to but not including index 3. Oops, this is still wrong. Let me just make that a positive value. So this was the length. This was the character at index 1. This is a substring. This is the actual string that comes back, right? Because it's multiple characters. It can't just be a character. And so it's going to be starting at A, the first one, up to but not including the third index, 0, 1, 2, 3. And so from 1 to 2 gives me a V, and that's what's returned here. All right, it's that up to but not including part that causes some issues for people. You forget that. Now we are used to comparing, if things with equal equals, and I didn't mean to put space there. If 1 equals 2, then print out, oops, the wrong thing there, print out somehow 1 is 2. So we use equal to compare primitive types, and of course that hopefully is not going to provide any information because 1 should not be equal to 2. With strings and other objects, we have to use this method called dot equals. So if name dot equals David, then let me just steal, oops, steal that. So if name dot equals David, print the strings are the same, and that's going to be true. Let me make another string. I'm going to make it a different way using the new keyword. Most objects are made with new. Strings are special that you can just use as a literal hanging out here. But this says make me a new string with this starting value. And now I can say if name equals other name, that should still be true because they're both the value David. But if I use dot equals, let's see what happens. I mean, not dot equals, if I use equals here, so I'm now comparing two objects using equals. I'm going to do an else here. The strings are different, I'm going to say here. Different. If I run this, okay, so dot equals says they're the same because they have the same values. The characters are the same. Equals says they're different, and that's because they're actually different objects here. One is the string David that's made one place in the computer memory. One is a new string David stored somewhere else. Their references are different, and we compare the references using equal. So it says they're different. This is a very common programming error. It's not illegal to say they're equal, but it means different things. This says they're exactly the same object. This says the data stored in them is the same, basically. So use dot equals with objects, especially strings. Okay, so strings are immutable. Once they're made, they can't be changed. So, for example, let's go back up to our name here. If I tried to say, for example, name char at index 2 equals some other character, I'm just not allowed to do it. I can't reassign a character inside that string. That doesn't mean that this name variable is stuck forever. For example, I can reassign it to be Sally. I should capitalize that. And that's perfectly legal. That just says make a new string Sally and assign it to name. It doesn't actually change the David string that was there before. That's still somewhere in computer memory. It just says now name is looking at this new string. So you can use that to modify strings. And if I did this and printed out name without the length, and I'm going to comment all this stuff out, then if I run this, I get the combo name David Sally, right? It takes the old value David, concatenates it with Sally, makes a new string out of that, doesn't change the string, and reassigns it to this David variable. So sometimes we want to build up a string, like with a while loop, and we want to start with sort of an empty string. So what is that? It's just two double quotes, nothing in the middle, no space, no nothing. And it's kind of like if you're using add up a bunch of numbers with a sum. We start with 0 and add numbers as we go. Here we're starting up with an empty string and concatenating more stuff on top of it as we go. So for example, here's a little method. If we wanted to add up multiples of 5, we're going to start at number 0. We're going to start with a string result equals empty string. And then while number is less than or equal to this end number, so like let's say that's 20, we're going to start off at 0. 0 is less than 20. And we're going to add in, concatenate with the current result, which is empty string, add in the string of 0, and then add in a new line, \n is a new line. Increment the number, repeat again. Now we have here a string that holds 0 in it, and we're going to add the string 5 to it, and the new line, and so on. So this is going to build up a string over time, and when we're done, we have a string that has multiples of 5s all stuck to it. Probably should be a space in here somewhere too, because it's all going to be smushed together into like one line. Anyway, just keep that in mind. Just because we make a string doesn't mean it's stuck there. We can reassign a new string to it, and we can actually do a computation that builds up like in a loop or something like that. Okay, so that's it. Please explore some of this stuff, and you'll get used to working with string methods as we do more with them.